Hi everyone, welcome to the lecture on computer organization and architecture. I am going to discuss different types of addressing modes in this video. So the first type is implied addressing mode. So in this addressing mode, the operand is implicitly defined by the instruction. Implicitly means indirectly. So uh, this is the simple instruction where we have uh, opcode, mode, and operand. This field is actually the address field. So in case of implied addressing mode, operand is of no use. It is not required at all. So when the mode bit says that it is implied addressing mode, then operand is ignored in this addressing mode. For example, we have an operation called add a. So here we are adding the value a with accumulator. Accumulator stores the result of some operations which are performed earlier. So suppose accumulator is holding the value 5 and the value of a is 10. So if we add these together, it will become 15 and 15 will be stored in accumulator. The previous value 5 will be replaced with 15. So the operand in this case is implicitly defined as the accumulator. So this operand is not required and accumulator acts as an operand in this case. So we all know that operand is the data. So while we perform some addition in mathematics, so if we add x plus y, then x and y are operand and the plus is the operation. So same in the same way, opcode here decides what operation is going to be performed, and mode bit uh, decides the addressing mode type. So let's check another type of addressing mode. So the next type is immediate addressing mode. In this addressing mode, operand value is present in the instruction. So here we have an instruction here operand the address field holds the operand value, not the address of the operand. It directly contains the operand value in case of immediate addressing mode. So we don't need any memory reference. This type of addressing modes are mainly used for um, initializing some um, value, index value, or uh, constants. The next type of addressing mode is direct addressing mode. In this addressing mode, address field contains the effective address of the operand. So effective address is the actual address of the operand. So operand is the data on which we will perform some operation. So it holds the this address field holds the uh, address of that operand on which we will perform operation. So this is the representation of an instruction where address field is pointing to the operand. The operand is in the memory at location. Suppose if it is 3001, then it holds the memory location 3001 and operand is inside the memory. So the next type is indirect addressing mode. Indirect addressing mode, the address field of the instruction contains the address of effective address or actual address. In direct addressing mode, is the instruction address field was containing the effective address, but here it is having the address of effective address. So from the diagram, it is clear that uh, it is pointing to the effective address. Suppose the memory location is 3004. So 3004 is again pointing to the operand. So we are getting the operand after two memory references. So in case of direct addressing, we were having only one memory reference, but in case of indirect addressing, we are having uh, two memory references. So this is for indirect addressing. The next type of addressing mode we have is register addressing mode. The address field specifies a register. So here the address field in the instruction is pointing to the register, and it is similar to direct addressing, but only difference is that the address field refers to a register rather than a main memory. So in case of direct addressing, it is the memory to which the address field is pointing. But in case of register addressing mode, uh, it is pointing to the register where the operand is present. So in case of register addressing mode, we are pointing directly to a register which holds the operand. So again we have the next type, which is register indirect addressing. The address field of the instruction specifies the register, and the register holds the effective address of the operand. So in this case, the path up to here is similar to uh, registered direct mode, register addressing mode, but it also contains reference to a memory where the operand is present. So here the register holds the effective address of the operand. First, the register is pointed by the address field of the instruction, and again the register holds the effective address of the memory location. Suppose if the memory location is 3000, then this register contains the address 3000, and inside the memory location 3000 operand is present. So operand is fetched with a single memory reference, the and operation is performed based on the opcode. The next type of addressing mode we have is displacement addressing mode. So in this mode, instruction contains two address fields, in which one is implicit register and another is explicit value. Implicit means indirect and explicit means direct value. The content of a register is added to the explicit value to produce the effective address. So from the diagram, uh, we can understand clearly, like this is the instruction. Here we have opcode, mode, uh, R and A, where R is specifying a register. It is specifying a register where we have some address or say some value, and the again A, where we have the explicit value, and all we are adding these together. Suppose the register contains 3000, uh, the value 3000, and the explicit value, that is direct value. Suppose if it is 5, means if we add these two, then it will become 3005, and it will 3005 is the effective address, uh, which says that the operand is located at the location 3005 in the memory. So this is 3005, and where the operand is present. So we are having one memory reference for getting the operand here, but the first two parts are registers. Register is giving the initial address, and then we are adding the explicit value to get the effective address. The next displacement type addressing mode is auto increment and auto decrement addressing mode. So with this addressing mode, both register direct and register indirect addressing is used. Suppose in register direct mode, we were directly getting the operand from the register. The address field was pointing to the register where operand was present, and in indirect addressing mode, the address part was pointing to the register which was holding effective address of the operand. Both cases are same. The only difference with auto increment is that after fetching the first operand, we are again incrementing the value of a register which points to the second register which holds the operand. So this is for auto increment with direct addressing, and the next one is auto increment with indirect addressing. So up to here it is similar to indirect addressing mode, but again we are incrementing the value of register, and then the effective address is uh, then we are getting the effective address from the register, and again the register is pointing to the operand in the memory location. Suppose the register value is 3000 here, and 3000 in the memory location is this location which contains the operand in the memory. In the same way, again we are incrementing the register value, and we are getting another effective address which holds the operand. So in the memory, this address, suppose if it is 3005, means it holds the operand inside the memory at location 3005. So effective address is 3005 here. The next type of addressing mode is base register mode. The base register mode contains the offset value in the address field. So in this instruction, the address field contains the offset value. Offset value means the predefined value, and then adding the base register with the offset will be the effective address of the operand. The name itself suggests that the this base register mode contains the starting address, that is base address inside a base register, and then we are adding the offset value together, and we are calculating the effective address. Suppose here the base address is 5000 and we are adding 10 with it, and we are getting 5010. So 5010 in the memory is holding the operand. So the base address means the starting address in case of any data structure like lists, arrays. So in case of arrays, the starting address, that is base address of is 5000, and then we are adding the offset value with the base register and getting the then we are getting the effective address, that is 5010, which holds the memory, which holds the operand in the memory location 5010. So this is all for base register. The next type of addressing mode is index register mode. Index register mode, the address field of the instruction specifies the base address, and certain index value is added with the base address to get the effective address of the operand. Here the instruction contains uh, address field where the address field has the base address, and the index register is having some index inside it. After adding these two, we are getting the effective address where the operand is present. So after adding 5010, we are getting 5010 in the memory location 5010, the operand is present. So the starting address is 5000. So both base register mode and index register mode actually works similar, but the address part of the base register contains the offset value, uh, but the address field of the uh, index register contains the uh, base address. The next type of addressing mode is relative addressing. It is also called PC relative. In this mode, instruction specifies opcode and offset value which can be added with PC to get the effective address of the target instruction. So here PC means program counter. We have a program counter which contains the address of the next instruction. Suppose it is holding the address 500. So and the address part of the instruction contains the offset value. Suppose the offset value is 5 here. So if we add these two together, it will calculate the effective address of the target instruction. So the in this case here we have instruction, not operand. Sorry for this mistake. So in case of operand, it will be the target instruction which needs to be executed next. So it is located at 505 in the memory. So uh, this is all for addressing modes. I'll be uploading later videos on different examples of addressing modes. Thank you for watching.